Hi everyone, in this video we are going to talk about how we can tackle dissolution questions in which we have a solid and we add it into either DI water over here or a solution contain a common ion, either Pb2 plus or Cl minus. Alright, so the only way for us to tackle this effectively is to draw the ice table. So when you tackle a question, the first thing you need to realize is whether it's a dissolution question or a precipitation question, or maybe it's an explanation question. So if it's a dissolution question, all we need to do is to be able to draw the ice table out. Right, so this is my PbCl2 solid dissociating to Pb2 plus and 2Cl minus. So what I have over here is ICE. This is the concentration. So let's take a look at the case on the left. So one, I'm going to write it down in black. So I'm not interested in this at all because this solid does not really have a concentration that I'm interested in, because I want to only be able to see what is present in the solution. Alright, so initially nothing is in the solution. Alright, this is DI water. Then once the solid goes in, I freeze time, nothing is inside. Now when I allow the system to equilibrate, it will start to dissolve until it reaches a state of equilibrium. So what happens is you will gain some Pb2 plus in the solution, right, and you will gain 2x of it. Basically we are looking at the mole ratio 1:2. This is what we have learned in the chapter of equilibrium. So we will get 2x and 2x over here. So what we want to do, alright, to find out how much of this solid has dissolved, or rather the solubility of it, we will just use KSP. Alright, usually either KSP is given or this value of x is given. So when we are given the KSP, then we'll realize that we can just find any of these amounts using this equation over here, and with that we will be able to solve for the solubility of PbCl2. Whereas in the second case, this is a common ion effect. So let's see. In this example, right, we started off with a solution of 0.1 mole per dm cube of Cl minus. So I'll start with 0.1 here, and as usual there's nothing, no Pb2 plus in the solution. So as the solid will start to dissolve, so there will be plus x and plus 2x over here. This is x, this is 0.1 plus 2x, and we know that since the dissociation is very small, so this is negligible in most cases. Sometimes you have to check the magnitude to see whether you can treat it as negligible. Usually the question will give you the data, and so I just have to substitute everything into this equation once again, and I will be able to solve for the value of x given KSP and this value over here. So as long as you figure out that the question is about dissolution, you can form this ice table, and eventually you will be able to calculate the things that you want to find out. So that is all there is to dissolution questions.